In the heart of the American plains, a biological engine is generating millions of pounds of product every single year.
This is nature's liquid gold, the only industrial fuel source created entirely by insects. But harvesting this raw power requires industrial might on a massive scale. We are talking about 500 jars a minute, moving at speeds the human eye can barely track. Purity is non-negotiable. Every ounce is scanned, tested, and verified by military-grade optics. Feeding a nation requires a logistical operation the size of a football field.
From the wildflower fields of the Dakota Plains to the supermarket shelf, this is the engineering behind modern honey.
It begins out here, in strategic locations chosen for their massive floral density. We use the Langstroth hive design, modular, stackable, and engineered for maximum industrial yield.
A single worker visits 1,000 flowers a day, collecting nectar drop by microscopic drop.
Inside the crop, enzymes break down complex sugars. It is chemistry at a microscopic scale. Managing this chaos requires a special breed of industrial farmer. They patrol thousands of acres, monitoring colony health across a sprawling grid.
When the flow is heavy, we add the honey super, a dedicated chamber just for surplus production. This is the payout. A frame fully capped, heavy with 3 pounds of pure honey.
Before we take it, we must calm the guard. Cool smoke masks the alarm pheromones.
Instead of brushing, high-velocity air gently clears the frame without crushing a single wing. Lifting these supers by hand is a recipe for injury. Instead, custom hydraulic loaders do the heavy lifting. A fully loaded flatbed can carry up to 40,000 pounds of raw product. This is high-density cargo, packed tight.
From the remote apiaries, the convoy begins its journey to the central processing facility. It is a logistical
Transport often happens under the cover of darkness. The cooler night air keeps the residual bees calm and prevents the wax combs from softening in the heat of the day.
Arrival at the processing plant. Here, the scale shifts from agricultural to industrial. Electric forklifts swarm the loading dock. They offload tons of raw honey in minutes, executing a choreographed dance of logistics to clear the bays for the next truck.
Accountability starts here. Every pallet is driven onto precision floor scales, logging the growth.
This supers are
It is a matter of fluid dynamics. Cold honey has high viscosity and clings to the comb. Warming it reduces drag.
Automation takes over. Robotic deboxers lift the heavy frames from their wooden casings, handling them with a delicate
This is the raw data of nature. A standard Langstroth frame, fully capped with white beeswax.
The frames enter the uncapping line. This stainless steel behemoth is designed to solve the primary obstacle between us and the honey, the wax seal.
Bees seal their storage cells with airtight wax caps to prevent fermentation. To extract the liquid, oscillating heated knives slice through the cappings with surgical precision. The heat melts the wax instantly, preventing the blade from dragging or tearing the delicate cell walls. The result is a perfectly exposed surface. The cells are open, glistening with nectar, and ready to release their contents under force.
Nothing is wasted. The severed wax cappings fall into a collection auger below. This byproduct is valuable.
For older, tougher combs, some lines employ a mechanical pricker. Thousands of tiny needles puncture the...
Once opened, the frames are caught by a chain conveyor. They march in lockstep toward the heart of the factory, the centrifugal extractor.
At the heart of the operation sits the radial extractor, a stainless steel titan capable of holding hundreds of frames at once. Precision automation slides the uncapped frames into the drum's carriage, locking them into a perfectly balanced radial pattern.
The engineering principle here is simple yet powerful: centrifugal force. It acts like a massive industrial salad spinner.
As the motor engages, the drum begins its rotation, slowly at first to ensure the load is balanced.
Within seconds, it ramps up to 300 RPM, generating G-forces strong enough to pull every drop of liquid from the comb.
The result is a golden rain. Thousands of tiny droplets are slung against the stainless steel walls.
Gravity takes over, pooling the extracted honey at the base of the tank, where it flows toward the sump.
When the cycle halts, the frames are bone dry. The wax structure remains intact, but the nectar is gone.
These empty frames are automatically ejected and stacked, ready to return to the apiary for the bees to refill. Meanwhile, the wax cappings sliced off earlier begin their own journey. This byproduct is far too valuable to waste.
A high-pressure screw press squeezes the cappings, separating the last remaining honey from the beeswax mush.
The dry wax enters a melting tank, transforming from a crumbly solid into a smooth, golden liquid at 145 degrees. Filtration removes impurities before the liquid wax is poured into industrial molds to cool and harden.
The resulting beeswax blocks are shipped out to become high-end candles, cosmetics, and pharmaceutical coatings.
Back on the main line, the raw honey is pumped through overhead stainless steel arteries toward the filtration stage.
First, it passes through a coarse strainer designed to catch bee legs, large wax particles, and other hive debris. The liquid settles in a large sump tank, allowing air bubbles introduced during extraction to rise to the surface and pop. Pressure pumps drive the honey through a series of progressively finer mesh screens, polishing the liquid to crystal clarity.
Crucially, true organic filtration must leave the microscopic pollen grains intact. Remove them, and it's no longer considered pure honey.
Throughout this entire process, thermal sensors ensure the temperature never exceeds 95 degrees, preserving the natural enzymes.
To prevent crystallization during shelf life, some commercial lines utilize flash heating. This rapid thermal...
Before bottling, the product enters massive stainless steel holding silos. These tanks act as the facilities.
Consistency is key. Large-scale paddles gently blend different floral sources, marrying the distinct notes of clover.
But before a single drop reaches a jar, it must pass the gauntlet of the quality control lab. Here, science verifies what nature produced.
Moisture content is critical. Anything above 8% invites fermentation, so technicians use digital reference.
Under the microscope, the truth is revealed. Pollen analysis confirms the floral source, distinguishing premium single-origin batches from standard blends.
Purity is non-negotiable. High-tech mass spectrometry scans for isotope anomalies, ensuring absolute
color is graded on the Fun scale, ranging from water white to dark amber. This optical classification determines the final market category of the batch. Finally, the human element. A sensory panel tests flavor notes, detecting subtle floral hints that machines might miss.
In this modern era, data is as important as the product. Every batch is digitally tagged, creating a traceability.
On the production floor, the bottling line roars to life. Empty containers are unscrambled, inverted, and black.
Filler is the heartbeat of the plant. Precision nozzles descend, injecting the golden liquid at a rate that defies the eye. Sensors monitor the flow to the milligram. The fill cuts off exactly at the rim, ensuring net weight compliance for millions of units.
Next, the rotary capper takes over. Mechanical chucks apply lids with calibrated torque, sealing the freshness inside. To guarantee safety, jars pass under an induction field. This non-contact heating fuses a foil seal to the rim, providing tamper evidence. Branding is applied at blur speeds. High-friction rollers slap labels onto glass and plastic with millimeter accuracy.
A CO2 laser etches the batch code and expiration date directly onto the plastic, a permanent mark for tracking and safety.
Before packing, a final sentinel stands guard. X-ray inspection scans through the density, hunting for even the tiniest fragment of glass or metal.
Automation handles the heavy lifting. Delta robots utilize vacuum grippers to arrange the jars into cases with relentless rhythm.
The cases are sealed, taped, and labeled. Within seconds, individual jars become shipping units, ready for the logistics network.
Robotic precision takes over at the end of the line, stacking cases into perfect geometric grids. To survive the journey, each ton of product is cocooned in industrial-grade polymer.
The finished inventory enters a cathedral of logistics, a warehouse stretching as far as the eye can see.
Beyond the standard liquid gold, some batches undergo a controlled transformation into creamed honey.
By guiding the crystallization process, engineers create a spreadable lattice structure that melts on contact.
But this industrial titan rests on a fragile biological foundation: the health of the hive.
These insects are the engine of agriculture, pollinating billions of dollars in crops while they forage.
To protect their workforce, producers are dedicating thousands of acres to pesticide-free wildflower sanctuaries.
When the production line halts, a new shift begins, sterilizing every inch of steel to pharmaceutical standards. Clean-in-place systems flood the internal arteries with scalding water, ensuring no residue remains.
As the temperature drops, the factory slows, and the apiaries face their greatest challenge: winter.
The harvest isn't just sugar. The hive produces propolis, a resinous glue prized for its antimicrobial power.
This facility is a global node, shipping American sweetness to markets across Europe and Asia. While domestic clover honey dominates volume, it competes with exotic medicinal varieties like New Zealand's Manuka.
Innovation continues to disrupt, with new tap extraction technologies simplifying the harvest for hobbyists.
The journey concludes in the retail aisle. Here, the golden product takes its place among thousands of others.
It ends as a staple in the American pantry, a simple sweetener that represents a complex chain of biology, logistics, and engineering.
We have witnessed a facility that processes millions of pounds annually, a relentless machine designed to capture and bottle the essence of summer.
Engineering exists here only to serve nature. Every pump, filter, and centrifuge is
Yet the system is fragile. Climate shifts and colony collapse order threaten the very foundation of this industry. Science is the countermeasure. Geneticists and biologists work tirelessly to breed resilience, ensuring these pollinators can withstand a changing world.
Some look to robotics for a solution. Micro-drones capable of artificial pollination are no longer science fiction, but a potential contingency.
But no machine can replicate the efficiency of evolution. The biological bee remains the supreme engineer of the natural world.
Flood. The cycle is eternal. Spring blooms, summer harvest, winter dormancy.
Inside the plant, the lines slow down. The roar of the centrifuges fades, leaving only out in the fields the workforce rests. The hive stands silent under the moonlight, waiting for the warmth of the morning sun.
We build the factories, the trucks, and the technology. But they do the work. The hardest workers on the planet.
Pure, golden, timeless.
From the flower to the frame, and the frame to the jar. This is the story of modern honey production.
For how it's made, I'm the narrator. Good night.